In the past couple of chapters, we've been looking at quadratic equations and just determining the roots of those equations. In this lesson, we're actually going to go backwards. So if we're given the roots of x equals -1 and x equals 4, how do we figure out the equation? Well, remember that when we had equations that were factored, each one of those factors told us what one of the roots was. So in simplest terms, we could say that x plus 1 is a root, and x minus 4. Because if I plugged -1 into here, I would get 0, which makes -1 a root, and then if I plug 4 in here, again I would get 0, making 4 a root. The thing that you have to pay attention to is this is the absolute simplest form of what we're doing, because we can always have some constant out front, which would change the numbers, but doesn't change the root. This particular problem gives us enough information so that we can actually figure out what the coefficient is on the quadratic. So we have x-intercepts of 1 and 3. So that means that our factored equation looks like this. And we know that it's got some a. So what we would do is FOIL this out. Now we're told that we have a minimum value of -1. So our vertex is -1. This h value is directly in between these two numbers. Sorry, brain freeze there. So h is equal. So we're trying to find the average of 3 and 1, and for that we get 2. So h is 2, so our vertex is actually located at 2, -1. And really we should have set this equal to y, so that we can figure out a. We have a times x is 2, 2 squared minus 4 times 2 plus 3, and that has to equal -1. Uh, 4 minus 8 is -4 plus 3, that's -1. So in this case, a is equal to 1, and our function is on this example, we're given a little bit different information. We're given the minimum, and we're told one of our zeros is 1. So we have to find everything else. When you're given a minimum, you're going to want to be in vertex form. So that's y minus k is equal to a times x minus h squared. So that becomes y plus 4 is equal to a times x minus 3 squared. And we're told one of our zeros is 1. So what that means as far as coordinates is the coordinate as at 1, 0. So now I just plug in 1 and 0 for x and y. So in this case, again, a is equal to 1. So the equation, we come back up here to that vertex form of the equation. And there's your equation. Now I know how much you guys love dog kennel problems, so we have a rectangular dog kennel. And I say it a lot of times, and very few people do this. You have to draw the picture. The house is one side of the kennel, so there's our house. And we have 60 meters of fencing. So determine the greatest possible area that can be enclosed. So what I'm going to do is I'm going to set this dimension as x, which means this is also x. And since x plus something plus x has to equal 60, this last side is 60 minus 2x. Now, a lot of you are going to want to make this a perfect square, or you're going to do some sort of guess and check. Let me assure you that on your test you will get a 0 for that. I actually will need to see the quadratic equation for this. So now we're dealing with area, and area is length times width. So that becomes negative 2x squared plus 60x. The maximum, probably don't remember like you're supposed to. The maximum occurs at negative b over 2a. That's going to be the x coordinate of the maximum. So that's going to be equal to your h. So that's equal to your h coordinate. So we would say h is equal to negative 60 over 2 times negative 2. So h is 15. That means that this dimension here is 15. So now we plug that back into this equation to find the area. And the area here is 450, so the largest area Last problem, we've got 20 members in a ski club and we have $8 per member dues. In order to encourage recruiting new members, we decide that for every new member we get, the dues for everybody gets reduced by 10 cents. So how many total members will our membership money be a maximum? So the first thing I want you to think about when you're approaching this problem is, how do you figure out the money? Okay, well, the money that you get is equal to the number of people times the amount of their dues, right? Okay, so that money is going to be equal to the number of people. Well, we currently have 20 people, but we're going to add some amount of people. And then we'll multiply that by our dues of $8 minus 10 cents for every person. Well, we're looking for a maximum. That tells me vertex. So because I'm looking for a vertex, I want to move this into vertex form. So the first thing I'll do is FOIL this out, and I get 160 plus 6x minus 0.1x squared. I'll rearrange that. Now I need to complete the square to put this in vertex form. You may be wondering how on earth I did that. Remember that you factor out this. So when I factor that out, I do 6 divided by negative 0.1. which actually gives me a negative 60x. I'm sorry, that should be a negative. Now, as I proceed to complete the square, $60 divided by 2 is 30. 30 squared is 900. Remember, if I add 900 here, you have to do the same here, but it's actually 900 times negative 0.1. 900 times negative 0.1 is negative 90. So I have to remember to subtract 90 from here. So here I have y minus 250 is equal to negative 0.1 times x minus 30 squared. I'm looking for the vertex, and actually it says for how many total members. Lots of us are going to say, oh, well, the h value is 30, so for 30 members. That is correct. The vertex here is 30 to 50. But that's 30 new members. Total members would be 30 plus 20. So, membership money will be a maximum for 50 total members.